Welcome to The Explainer. Today, we are diving into a technology that's, well, it's straight out of science fiction. We're talking about merging the smarts of AI with the totally mind-bending rules of quantum mechanics. And the big goal here? To build the communication networks of the future, networks that are going to be unbelievably fast, super efficient, and just plain intelligent.
Okay, so let's jump right in by looking at a massive problem that's right around the corner. Our digital world, everything we do, is growing at an insane pace. And the very networks that hold it all together, they're being stretched to their absolute breaking point.
You know, we're all excited for 6G, and maybe even thinking about 7G down the line, a world where everything is just instant. But, and this is a big but, getting there isn't just a simple upgrade. It comes with some seriously demanding requirements. As we push for these next-gen networks, our current tech is basically about to hit a brick wall. We need things to be instantaneous, with almost zero lag. We need to handle astronomical amounts of data. And on top of all that, we need to do it using way, way less energy. The problem is, our classical computers, even our best AI, they're just not built for this. They can't keep up. So how do we smash through that wall? This leads us to this really cool what-if question. What if we could build a network that learns like a human brain, but computes using the fundamental rules of the universe itself? And that's where our solution comes in. Let me introduce you to the hero of today's story, the Quantum Neural Network, or QNN for short. Now get this, this isn't just about building a faster chip, it's a totally different way of thinking about computation. Okay, so what is a QNN? Well, to put it simply, it harnesses the strange and powerful rules of quantum physics. You know, that whole idea that a particle can be in many places at the same time, what they call superposition, and uses it to process a ton of information all at once. This lets them make decisions and solve problems so complex that our best supercomputers today would just give up. Okay, but here's the catch, and it is a huge one. As the source material calls it, there's an exponential wall. See, trying to describe a full quantum state is just monumentally complex. It's a massive bottleneck. Imagine trying to write down the exact position of every single atom in the universe all at the same time. Yeah, it's kind of like that. So the big question becomes, how do we deal with this insane complexity? We need a way to kind of tame it, to simplify the problem without losing all that quantum magic. And lucky for us, that's where this really brilliant mathematical tool comes into play. It's called a tensor network, and you can think of it like a super smart compression tool, but for quantum information. It lets us draw a simplified map of a really complex quantum system, which suddenly makes the impossible seem, well, manageable. And this visual here is a great way to see it. Instead of one giant tangled mess of information, the tensor network breaks it all down into these smaller connected pieces. And that structure right there, that is the absolute key to making all of this practical. This comparison just nails it. The old way, what the source calls the volume law, is like trying to listen in on every single conversation happening in a whole country all at once. It's impossible. But tensor networks use what's called the area law. It's like being smart and only focusing on the most critical information being exchanged at the borders. It is a total game changer for efficiency. Okay, so this is all great in theory, right? We've got a huge problem, that 6G wall, and we have this really clever potential solution with tensor networks. But the million-dollar question is always, does it actually work in the real world? Well, let's look at the data. Researchers, and this is detailed in Chapter 1 of the source material, put this exact idea to the test. They built a hybrid model, one that takes the best of the quantum world and the best of the classical computing world and smashes them together. And what they designed was this really elegant four-step process. First, you start with your complex network data. Then, the quantum part, the QNN, does all the heavy lifting. It sifts through that data to find the most important patterns. After that, it hands off those super optimized features to our trusty classical AI models. And then, the really cool part, they create a feedback loop. So the two systems are constantly talking to each other, constantly learning and getting better. All right, this is the moment of truth. They tested this new hybrid system against your standard machine learning and even against a more basic quantum approach. So, how did it do? The results, Well, they were nothing short of dramatic. I mean, look at this. The proposed hybrid model just blew everything else out of the water. It achieved over 50% higher spectral efficiency than traditional AI. It used 33% less energy. And get this, it literally cut the network latency in half. This isn't just an improvement, it's a massive leap forward. So yeah, this is an incredible result, right? It totally proves the concept works. But the implications here go so much further than just getting faster internet on your phone. What we're really looking at is a foundational breakthrough in technology.
I mean, this is the exact same kind of technology that could power the next huge wave of innovation. Think about it. Smarter drug discovery in healthcare, truly autonomous cars that can react in an instant, more secure communications, even highly personalized therapies for mental health, all running on a network built with quantum intelligence.
And, this really gets to the heart of it. As the authors of our source materials say in their dedication, this is not just about building tech for us right now. It's about inspiring and empowering a whole new generation of innovators to build a future that, honestly, we can't even imagine yet. So here's the bottom line. The foundation for this new world is being laid right now. We're not just building a faster network, we're crafting the tools for a completely new era of innovation. And that really just leaves one big question, doesn't it? What are we going to choose to build with them? Thanks for joining us on The Explainer.